Hi everyone, welcome back to Made Everything Official. Steel pole production begins as coiled steel is fed into a straightening machine, where rollers flatten and align the material into a long, straight strip. Accurate straightening is critical, as any remaining curvature would affect forming quality. The straightened strip then enters a press-forming stage. Controlled pressure bends the flat steel into a cylindrical shape, creating a uniform pole with consistent diameter along its length. Next, plasma cutting systems produce pole components from thick steel plates. Base plates and mounting parts are cut with precision to ensure clean edges and correct dimensions. After welding, final finishing removes weld residue and prepares the surface, completing the transformation from steel coil into a finished steel pole. At Wind Towers Scotland Limited in Campbelltown, large steel plates are shaped and assembled into wind tower sections used for renewable energy infrastructure. The process begins with a long, heavy steel plate being fed into rolling machines that gradually bend it into a circular shape. Controlled rolling force ensures the plate forms an even ring without stressing the material or altering thickness. Once the circular section is formed, the two ends are brought together and welded along the vertical seam. This weld closes the ring, creating a cylindrical tower shell. Careful weld control is essential here, as the seam must withstand both structural loads and environmental forces once installed. Individual cylindrical sections are then lifted by overhead cranes and positioned vertically. One section is aligned on top of another, forming a taller tower segment. Welders join these sections together along circumferential seams, permanently connecting them into a single, continuous tower structure. After welding, grinding operations smooth the external welds, removing excess material and creating a uniform surface for coating. When structural assembly is complete, two large cranes transfer the tower section to a separate finishing area. Here, the tower enters the painting process, where protective coatings are applied to guard against corrosion in harsh offshore and onshore environments. After painting, the finished wind tower section is moved out of the factory and prepared for transport. Heavy-duty trucks are positioned on site, and cranes load the tower securely onto specialized transport equipment. The journey continues as the tower sections are transported from the manufacturing site to Campbelltown Harbor. From there, they are prepared for onward shipment by sea. Spiral steel pipe production begins as wide steel coils are fed into the forming line, where the strip is angled and bent into a continuous circular spiral. As the steel wraps into a tube, the edges meet along a helical seam. Dual seam tracking systems monitor this joint in real time, keeping alignment stable as the pipe forms. Welding heads then fuse the spiral seam continuously, joining each rotation into a single, rigid pipe with consistent diameter. By combining spiral forming, precise seam tracking, and continuous welding, steel coils are efficiently transformed into finished spiral pipes ready for use. Thick steel plate rolling at Pirasolda demonstrates how cold calendaring is used to form heavy flat plates into precise cylindrical sections for industrial applications. The process begins with a thick steel plate being positioned into the rolling machine. Multiple rollers apply controlled pressure, gradually bending the flat plate into a curved profile without heating the material. Precise control is essential, especially with thick sections, to avoid cracking and to maintain uniform curvature. As rolling continues, the plate edges are progressively formed until the desired radius is achieved. Special attention is given to the plate ends, where additional forming ensures proper alignment for closure. Once the curvature is complete, the cylinder edges are brought together and closed to form a complete shell. Through controlled cold rolling, accurate edge forming, and final welding, heavy steel plates are transformed into cylindrical components ready for structural and equipment assembly. Across multiple industrial sectors, automated welding and production systems from PEMA demonstrate how heavy steel fabrication can be standardized, controlled, and scaled for demanding applications. The process begins with large steel components entering automated production cells. Plates, beams, shells, and fabricated sections are transferred by rollers, rotators, and handling frames that position each workpiece accurately before welding starts. Precise positioning is essential, as these components are often used in load-bearing structures and pressure-critical environments. For cylindrical and curved products, rotating positioners synchronize the movement of the workpiece with the welding torch. This allows continuous welding without interruption, improving seam uniformity and reducing defects caused by manual stop and start operations. Seam tracking and adaptive control systems monitor joint position in real time. These systems automatically adjust torch position to compensate for tolerances, material variation, or minor distortion, ensuring accurate weld placement even on large or complex assemblies. As production continues, components move through multiple automated stations. Depending on the product, this may include internal welding, attachment of stiffeners, mounting of brackets, or joining of subassemblies into larger structures. Automation ensures repeatability while reducing reliance on manual labor. Throughout the process, digital production control systems record welding data and process parameters. This information supports quality assurance, traceability, and compliance with strict standards required in industries such as shipbuilding, offshore construction, wind energy, and oil and gas. These robots follow three-dimensional weld paths along curved and irregular joints. Advanced motion control and seam tracking enable the torch to maintain correct orientation and distance from the joint, even as the surface changes direction. By adapting to non-linear seams, automated welding ensures consistent quality across complex structures without sacrificing speed or accuracy. After welding is completed, assemblies are transferred for inspection and downstream operations. Visual checks, dimensional verification, and non-destructive testing confirm structural integrity before components move on to surface treatment, final assembly, or logistics handling. In addition to straight and circular seams, robotic welding systems are designed to handle complex joint geometries. Articulated robot arms can access confined spaces and awkward angles, allowing welds to be applied where manual welding would be difficult or inconsistent. This flexibility is critical for components with intersecting plates, curved transitions, or internal reinforcements. By integrating intelligent material handling, robotic welding, real-time monitoring, and data-driven control, PEMA welding automation systems enable efficient, high-quality production across a wide range of heavy industrial applications. Manufacturing of torus spherical heads begins with thick steel plates prepared for forming, a process commonly used for pressure vessels and transport tanks. The plate is first positioned onto a forming press, where controlled force gradually bends the steel into a curved profile. Step by step, the flat material is shaped into a domed form, with pressure applied evenly to maintain thickness and structural integrity throughout the surface. As forming continues, the curvature becomes more pronounced. Specialized tooling guides the steel into a toruspherical geometry, combining a spherical crown with a rounded edge transition. This shape is critical for distributing internal pressure evenly when the head is installed on tanks or autoclaves. Depending on the application, additional machining or edge preparation may be performed to ensure accurate fit-up during assembly. The finished heads are then prepared for welding, coating, or direct integration into pressure vessels and transport tanks. Through controlled forming, precise trimming, and careful inspection, flat steel plates are transformed into high-strength domed heads suitable for demanding industrial and transportation applications. At this facility, large steel heads and vessel components are formed using a 3,000-ton hot forming press, a key machine for shaping thick metal into high-strength tank and dish heads. The process begins with pre-cut steel blanks heated to high temperatures in a furnace. Heating the material makes it more ductile and able to withstand deformation without cracking. Once the blank reaches forming temperature, it is transferred into the hot forming press. The 3,000-ton press then applies controlled force to the heated blank, pressing it into a matched die set that defines the final shape of the tank or dish head. Because the material is hot, it flows more easily and fills the die cavity completely, producing smooth contours and accurate geometry critical for pressure-bearing applications. During forming, sensors and controls monitor press force and temperature to ensure consistent results across each cycle. Proper heat and load control prevent defects such as thinning, warping, or incomplete fills, which could compromise strength. Once cooled, the component is transferred to trimming stations where excess flash is removed and edges are refined. Subsequent finishing operations may include grinding and machining to achieve final tolerances and surface quality. After forming, the component is removed from the press and allowed to cool under controlled conditions. Cooling stabilizes the microstructure and minimizes residual stress, preserving mechanical properties required in vessel and tank service. Inside Expert Crane's factory in Cleveland, steel components are fabricated and assembled to create crane structures engineered for demanding industrial lifting applications. Each stage of production is organized to ensure structural strength, dimensional accuracy, and reliable integration of mechanical and electrical systems. Manufacturing begins with preparation of the main steel plate that will form the core of the column. Smaller steel plates are carefully positioned and welded onto this long base plate. These smaller plates act as internal stiffeners, creating a reinforced skeleton inside the column. Once the internal stiffeners are fully secured, 3 additional long steel plates are brought into position around the core. These plates are aligned precisely and welded together edge to edge, enclosing the internal structure to form a rectangular box column. Welders follow a controlled welding sequence to manage heat input evenly across the length of the column. This approach minimizes distortion and ensures the finished structure remains straight, rigid, and dimensionally stable. After structural welding is complete, the column moves into surface finishing operations. Grinding tools are used to remove excess weld material and smooth raised seams along the exterior faces. This step not only improves the visual appearance of the column, but also eliminates sharp edges and prepares the surface for protective coatings. Smooth, even surfaces are essential for both coating adhesion and long-term durability. The column then enters the painting and assembly stage. Protective paint systems are applied to shield the steel from corrosion and environmental exposure. Coating thickness and coverage are controlled to meet industrial standards for outdoor and heavy-duty use. While painting is completed, electrical work is carried out in parallel. Wiring, junction boxes, cable routes, and control enclosures are installed directly onto the column, integrating electrical functionality into the steel structure. With mechanical fabrication and electrical installation complete, the finished columns are moved to the final handling area. Overhead cranes lift the large structures safely and position them alongside other crane components produced in the factory. These assemblies are then carefully loaded onto transport trucks and secured for shipment. During loading, overhead cranes carefully lift the finished columns and associated components onto transport trucks in a controlled sequence. Each piece is positioned precisely, then secured using restraints to prevent shifting during transport. Once fixed in place, the load is covered with protective tarps, shielding the steel from weather exposure and ensuring safe delivery to the installation site.